Picture the tallest rocket ever built, standing taller than the Statue of Liberty in South Texas.
This is Starship, SpaceX's bet on turning humanity into a species that lives on more than one world.
It's not just a rocket. It's the most ambitious machine anyone has ever tried to fly. Every inch of it was built to answer one impossible question: how do we get to Mars? To understand Starship, you have to go back to a scrappy company nobody took seriously. In 2002, Elon Musk founded SpaceX with a simple, almost reckless goal in mind.
He wanted to make spaceflight so cheap that going to Mars felt inevitable, not impossible. For years, SpaceX built smaller rockets, learning how to land boosters instead of throwing them away. Falcon 9 proved reusability could work, landing again and again on drone ships at sea. But Musk always said Falcon 9 was just a stepping stone to something much bigger. That something bigger became Starship, a fully reusable system unlike anything flown before it. Starship isn't one rocket, it's actually two enormous vehicles stacked on top of each other.
The bottom half is called Super Heavy, a booster taller than a 20-story building. The top half is Starship itself, the spacecraft that carries people, cargo, or satellites. Together, stacked up, the whole vehicle stretches about 400 feet into the Texas sky. That makes it taller than NASA's legendary Saturn V rocket from the Apollo moon missions.
Both stages are built from shiny stainless steel, not the carbon fiber everyone expected.
Stainless steel is heavier, but it's cheap, strong, and survives the heat of re-entry.
Musk once joked that steel makes Starship look like it flew straight out of a 1950s sci-fi comic. Under the hood, both stages are powered by engines called Raptors, SpaceX's most advanced creation. Raptors burn liquid methane and liquid oxygen, a fuel combination chosen with Mars in mind. Why methane? Because it can theoretically be made on Mars, using local ice and carbon dioxide. That means a future Starship could refuel on Mars and fly itself back home. Super Heavy alone carries 33 Raptor engines clustered together at its base. 33 engines produce more thrust at liftoff than any rocket in human history. When it fires up, Super Heavy generates roughly 17 million pounds of force. That's more than twice the thrust of NASA's Saturn V from the Apollo era. The ground literally shakes for miles when Starship lights up at Starbase, Texas. Starbase itself is a small company town SpaceX built from scratch on the Gulf Coast. It sits near Boca Chica Beach, close to the border with Mexico. What was once empty wetland is now a full-blown rocket factory and launch site. SpaceX calls its massive assembly building the Star Factory, built to churn out rockets fast. The goal is almost unbelievable: build a brand new Starship every single day. No aerospace company in history has ever tried to manufacture rockets at that speed. Traditional rockets take years to build. SpaceX wants Starships built like cars on an assembly line. That's the only way to make Mars colonization affordable, instead of a billionaire's fantasy. But building the rocket was only half the challenge SpaceX had to solve. The harder problem was proving Starship could survive the punishing trip back from orbit. Coming home from space means slamming into the atmosphere at over 17,000 miles per hour. Friction with the air heats the spacecraft's surface to nearly 2,700 degrees Fahrenheit.
To survive that, engineers covered Starship's belly in thousands of black hexagonal heat tiles.
Each tile is custom-shaped, and losing even one can risk the entire vehicle. Early test flights showed just how brutal re-entry heating really is in practice. SpaceX's approach to all of this has always been blunt. Build fast, test fast, break things. Musk's philosophy is that failures teach more than years of quiet computer simulations ever could. So instead of hiding failures, SpaceX live streams almost every test flight to the entire world. The very first full Starship test flight happened back in April 2023, and it did not go well. The rocket tumbled out of control minutes after liftoff and had to be intentionally destroyed. Debris and dust rained down for miles, and the launch pad itself was badly damaged. Instead of hiding from the disaster, SpaceX called it valuable data and got back to work.
Engineers rebuilt the launch pad, adding a massive water deluge system to tame the flames. Flight after flight, small improvements chipped away at problem after problem, one piece at a time. By the fourth and fifth test flights, Starship was surviving stage separation and reaching space. Then came one of the most jaw-dropping moments in modern rocketry, caught live on camera.
SpaceX attempted to catch the falling Super Heavy booster using giant metal arms on the launch tower. Engineers nicknamed those arms chopsticks, because that's exactly what they looked like in action. As the booster fell back from space, it slowed itself using its own engines. Then, incredibly, the tower's arms swooped in and caught the booster in midair.
Millions of viewers watched live as a 20-story rocket landed gently in a giant mechanical hug.
It was the first time in history a booster of that size was caught, not landed on legs. Catching the booster instead of landing it saves enormous amounts of weight and complexity.
No landing legs means more room for fuel, cargo, or future passengers on board.
That single catch instantly became one of the most replayed rocket videos ever filmed.
But not every flight has ended in triumph, and SpaceX doesn't pretend otherwise.
Several early Starship upper stages exploded during testing, sending fireballs across the Gulf of Mexico.
One explosion during ascent even forced airlines to briefly reroute flights near Florida's coast.
Debris fell near the Turks and Caicos Islands, sparking real concern among nearby residents.
Regulators at the Federal Aviation Administration paused launches multiple times to investigate what went wrong. Each pause meant months of waiting, redesigning, and retesting before SpaceX could fly again.
Critics said the approach was reckless. Supporters said it was simply how rockets get built. Either way, each explosion produced new data that shaped the next version of the vehicle.
By 2026, SpaceX had moved on to an upgraded design called Starship version 3.
Version 3 is taller, carries more fuel, and uses a stronger version of the Raptor engine.
That upgraded engine is called Raptor 3, simplified and more powerful than earlier versions.
In May 2026, Starship's 12th flight test lifted off from a brand new second launch pad. It was the very first flight for the version 3 booster, ship, and engines together. All 33 engines on the booster ignited, and the rocket roared off the pad. One engine shut down during ascent, but the booster kept climbing toward the edge of space.
Starship separated using a dramatic maneuver called hot staging, firing new engines before letting go of the old stage.
The upper stage's 6 engines lit perfectly, pushing Starship onward toward orb. For the first time, small Starlink satellites were released mid-flight to photograph Starship from space. Those images gave the world a stunning outside view of the ship soaring above Earth. Meanwhile, the Super Heavy booster attempted its usual boost-back burn to return towards Starbase. This time, not all of its engines relit, and the booster couldn't complete the maneuver. It came down hard in the Gulf of America instead of a gentle, controlled splashdown. Despite that, the upper stage pressed on, coasting halfway around the planet toward the Indian Ocean. It re-entered the atmosphere, gathering crucial data on its heat shield and structural limits.
In its final moments, engineers deliberately stressed the ship's rear flaps to test their breaking point.
Then Starship splashed down upright in the ocean, just as SpaceX had hoped it would. Elon Musk called the flight epic, even with the rough ending for the booster. It was also a historic week for SpaceX, far beyond just rocketry and engineering.
Just 2 days earlier, Musk had announced plans to take SpaceX public through an IPO. That IPO could value the company at more than $1.2 trillion. Days later, SpaceX filed prospectus documents revealing new details about Starship's ambitions for the public. In those filings, the company said it's building Starship to carry 100 tons into orbit. That's roughly the weight of about 70 family cars launched into space in a single trip. It's an amount of cargo no rocket in history has ever carried, and fully reusable too. After the 12th flight, the FAA required SpaceX to investigate what happened to the booster. It's a routine step SpaceX has faced before, following earlier mishaps during testing. Every investigation ends the same way. Engineers dig through data, then fix, then fly again. This relentless cycle of test, fail, fix, and retest is the heartbeat of the Starship program. It's a strategy borrowed from Silicon Valley software culture, not traditional aerospace engineering. Traditional rocket builders spend a decade perfecting a design before ever launching it once.
SpaceX instead launches early, learns fast, and rebuilds the rocket almost every few months.
That speed is exactly why Starship has already flown a dozen times in just a few years. But Starship isn't just about rockets breaking records. It's about a much bigger mission. NASA has chosen a modified version of Starship to land astronauts back on the moon. That mission is called Artemis, named after the twin sister of Apollo in Greek mythology. Under this plan, astronauts launch on NASA's Orion capsule, not on Starship itself. Orion will dock with Starship in lunar orbit, then astronauts climb aboard for the descent. Starship will carry them down to the moon's surface near its icy south pole. That region is believed to hold frozen water that could one day support a permanent moon base. It would be the first crewed moon landing since Apollo 17, way back in 1972. To pull this off, Starship first needs to master an incredibly tricky orbital fuel transfer. Because Starship burns so much fuel reaching orbit, it needs to refuel before heading to the moon. SpaceX plans to launch tanker versions of Starship just to carry propellant into orbit. Those tankers will dock with a lunar Starship and pump fuel from one ship to the other. It's a maneuver that's never been done before at this scale in the history of spaceflight. Some estimates suggest more than a dozen launches might be needed for a single moon mission.
That kind of launch pace only becomes possible if Starship becomes fully and rapidly reusable.
It's also why Starbase's Star Factory matters so much to the entire Artemis timeline.
Building rockets like cars isn't just efficient, it's the only way this plan can work.
Of course, SpaceX isn't the only company chasing a moon landing for NASA's astronauts.
Blue Origin, founded by Jeff Bezos, is developing its own lunar lander called Blue Moon.
NASA has hedged its bets, letting both companies compete to prove their landers are ready. Whichever lander proves safest and most reliable first may fly the actual Artemis mission. That competition is pushing both companies to test faster and iterate more aggressively. But even beyond the moon, Starship's true North Star has always been the red planet. Musk has said publicly that he wants to send an uncrewed Starship to Mars this decade. The idea is to test landing systems on Mars long before any human ever climbs aboard.
Eventually, SpaceX imagines fleets of Starships launching together during Mars transfer windows every 2 years.
Those windows happen because Earth and Mars align favorably only once every 26 months.
Missing one window means waiting more than 2 years for the next launch opportunity.
It's an audacious plan, but SpaceX has already begun selling seats on future missions.
Wealthy space tourists have signed contracts for private trips around the moon aboard Starship. One of them, entrepreneur Chun Wang, has even booked a seat on the first Mars mission.
Wang previously flew with SpaceX on a record-breaking polar orbit aboard a Dragon capsule. These early customers are essentially funding and validating the technology years before it's fully proven. Meanwhile, engineers keep grinding through test after test, refining tiles, engines, and flight software.
Every static fire, every fueling test, every static engine burn adds another piece of data.
At Starbase, workers even nicknamed one testing phase the Starship Shell Game, moving vehicles between pads.
Ship prototypes get numbers instead of names, like Ship 40 or Booster 20, tracked meticulously.
Each new ship in the lineup represents lessons learned from every single one before it. It's part science, part manufacturing marvel, and part high-stakes theater broadcast to millions.
Fans camp out along the beach just to watch these enormous rockets rumble into the sky. Locals in the small town of Starbase have watched their community transform overnight into a spaceport. Some worry about environmental effects on nearby wildlife refuges along the Texas coastline.
Regulators continue monitoring the site, balancing rapid innovation against genuine environmental and safety concerns. Despite the controversy, most experts agree Starship represents a genuine leap in rocket technology. No other vehicle has ever combined full reusability with this much raw carrying capacity. If it works as planned, launch costs could drop by orders of magnitude within years.
Cheaper launches could mean new space stations, moon bases, and eventually cities beyond Earth.
It sounds like science fiction, but so did landing rocket boosters just over a decade ago.
SpaceX turned that fiction into a Tuesday afternoon habit at Cape Canaveral and Starbase alike.
Starship is simply the next chapter in that same relentless pursuit of the impossible. Every explosion, every scrapped booster, every rough splashdown pushes the program one step closer. The engineers at SpaceX aren't chasing perfection on the first try, they're chasing progress. And progress, however messy, is exactly how humans have always pushed further into the unknown. Somewhere between Texas launch pads and Martian dust storms, that progress is quietly being written. Starship isn't finished yet, but it's already rewriting what we thought was possible in space.